We want to solve calculation questions on in physics rather. Then I want to look at questions on magnetic field, binding energy. We'll be looking at questions on elasticity. Also, we'll be looking at questions on the moment and equilibrium of forces and even vector. Now, let's start with the first question. The first question is called talking about what? Binding energy. It said calculate the amount of energy released if 0.8 kilogram of radium is totally what? Fissioned. So calculate the amount of energy released if 0.8 kilogram of radium is totally fissioned. We are given what we know that the binding energy when you are given mass in kilogram is equal to what? MC change in what? And change in mass rather times what? Speed of light square. Then we also have another one that has to do with what? Binding energy equal to what? Change in mass defect times what? 931 mega electron volt. That is if change mass defect, which change in mass is what measured in atomic mass unit. We use this one when the change in mass is measured in kilogram. And don't forget the speed of light is your c, which is given to us here. So the mass defect, we assume the mass given to us, which is 0. That is the mass release. The difference in mass defect times what? What is our speed of light? C. We're going to use this one. 3 times 10 by what? 8 all square. So the binding energy becomes what? Don't forget that this one is set as 0.8 times what? Square of 3 is 9. Then 8 times 2 is 16. That is about 16. So 0.8 times 9 give us 7.2. You can press a calculator to confirm it. 16 what? Joules. So the answer is what? 16. Option C. 7.2 times 10 power 16. Number 2 calculation say calculate the magnetic force experienced by an electric what? Electron moving in a magnetic field with a flux density of 100 watt Tesla with the velocity of 10 power 8 meter per second in the direction of perpendicular to the what? To the magnetic field. Now, in this case now, looking at the parameters, we are giving what? Magnetic field as 100 Tesla. Then we are given what? Velocity as what? 10 power 8 meter per second. We are given what? Charge. Charge is given as what? E. Don't forget our charge here is likely to be what? Charge of electron, which is 1.6 times 10 power minus 19 coulomb. Now, they say they are perpendicular. I mean, theta is equal to 90. You check the question, they said what? The direction of perpendicular what? They said the velocity is in the direction perpendicular to the magnetic field. So, if what the angle between the magnetic field and what velocity is 90, that means maximum force is produced on the charge, the magnetic field, which is what? QVB. So in that case, what's our Q? Q is 1.6 times 10 power minus 19 times 10 power 8 with velocity times 100 Tesla. So what we are going to have now, our final answer, I mean, that becomes what? 100 times 10 power 8 is 10 power 10. That is 1.6 times 10 power 10 power 10 removed from 10 power minus 19 minus 10. Minus 10. Okay, minus 9, sorry. So we are going to what? Look at the options. So the answer will be what? B, which is what? 1.6 times 10 power what? Minus 9 Newton. Now don't forget that what? They gave us what? This one is given as what? 8. You understand? So it's given as 8. So if you add this one, this is 10 power 8 plus 10 power 2. You use 10 power 10. Then minus 10 plus 10. If you take what? Indices, 10 power minus 19 plus 10. Well, minus 9. That's how we have minus 9, which is option B. Now, having known that, now let's look at the next question, which is, this one is under elasticity. Now, we are given 10 when the extension is 2. We are given 20 when the extension is x and 30 when the extension is 6. The force is 30 when the extension is 6. Now, in this table, we are assuming that the elastic limit is not exceeded, although the question is not stated. It was not stated in the question, but that's what I want to assume to solve our problem. Now, we know that the force applied is directly proportional to what extension according to Hooke's law. And if you remove the proportionality, you have KE. So that means that K is equal to F over E. So we can use the formula F1 over E1 equal to F2 over E2 to solve our problem. Now let's assume that F1 is which one do you want us to use? Okay, let's use 10 as our F1 over E1, which is T, 2. S2 is what? F2 is what? 20 over E2 is X. Cross multiply. What I would have 10X is equal to what? 40. Divide both sides by what? By 10 or by coefficient of X. So what do you have? S now becomes what? 40 divided by what? 10. I want to have what? 4 meter. So the answer is 4 meter. Let's go to the next one. If the power of a lens is minus 4, what is the focal length of the what? Of the lens that we're looking for? Now, power of lens equal to 1 over F. Don't forget. Power of a lens. If this is plus when it's converging lens, it is minus when it's diverging lens. So in this case now, we use minus, or we don't even need to bother ourselves. We just substitute our F into it. We're going to have what? 1 over minus 4. If you divide 1 over, that means 1 inverse of this one will give us what? Minus 0.25 meter. You understand? So that is what will be option what? C. So take inverse of that power. Don't forget that, sorry, this is power, this is F, and this is power. Sorry, I missed it up. Sorry for that. Because E for power is the same thing, but F is equal to 1 over P, just like the same way power is equal to 1 over F. You understand? F equal to 1 over P. Power of a lens is equal to inverse of focal length. We have different formula for it. Although they are the same formula, but we can say F or power of a lens equal to 1 over F in what per meter, or you can also say that like this one now, they didn't give us unit. Normally it's supposed to have per meter in the question, and the person that sent that question to us. So for diopter, you can also be measured in diopter. You can also be measured in per centimeter. This is for per centimeter. You can also be measured in diopter. So diopter, capital letter D. So in that case, it depends on what they measure it to be. But this one is supposed to be per meter, if at all they want to, or G. So this one now is minus 0.25 as our answer. This question, the next question is on equilibrium, which is second to the last question. It says a uniform bar AB of length 5 meter and mass 6 kg balance at what? As shown. That they're giving us all the diagram we needed to do. In the diagram above, the weight of 100 Newton is applied at P, which is here, this point P, and the what? Such that PB is 2 meter. Calculate the reaction at B. Now, for us to calculate reaction at B, there are two reactions here. If you actually look at it, we have one going up is what? Because upward force will be equal to downward force. We assume that since it's balanced, it means that it's in equilibrium. So Y1 plus Y2 should be equal to what? 160 Newton, which is the downward forces are what? 60 Newton and 100 Newton. While the upward forces are what? Y1 and Y2. So if you understand that now, it then means that this particular one must hold. Although we are not troubled. You know why? Because we are looking for the reaction force here. There's a reaction here, which is Y2. So if you want to find Y2, take moment about what? Take moment about what? Y1. So if you take moment about Y1, it means that all the forces will now be focusing on this one. This one will move here. This one will move here. So we have 2 clockwise moment and 1 anti-clockwise what? Moment, in which the clockwise must be equal to what? Anti-clockwise, for the uniform bar to experience balance or equilibrium. So in this case now, what I want to do is what? 60 Newton, which is what the force. This clockwise, I'm taking this one as clockwise, this anti-clockwise. So 60 Newton, what the perpendicular distance to this A, point A, that we're taking moment about. It will now be what? 2 meter plus what? What is our this there? What is our force again? Clockwise is 100 times what? 100 Newton times what? 3 meter It's because so the only anti-clockwise we have is y2, which we are looking for. The action at this one is y2 times what is our distance? Is what from here to this place, because anti-clockwise is 5 meter. So if you divide all through by 5, divide all through by 5 meter, what do you have? This one will give us 120 Newton meter plus 300. 300 plus 120 will give us 420. And 420 divided by what? By 8. We'll be having 84 Newton, because we are now going to have that's what? 4. That means y2 now be what? 420 Newton meter divided by 5 meter. And that would be 84. So 84, if you make y2 solve the formula, I want to have the reaction that will be acting here as what? 84 Newton. But funny enough, you can still calculate y2 if you ask, because you can use this formula to calculate your y1 rather. You can calculate your y1. You don't need to go over again and take moment about this point. But we are focused on the question given to us. So the answer is what? A. Now, let's solve the last question. The last question is very easy. Now, if you want to solve this last question, ask yourself, which direction is X going and which direction is Y going? Now, you must ask yourself that question. You know why? Because Y is going in the same direction as Z. And when two vectors are going in the same direction, we add them together. When they are going in opposite direction, we subtract. So, Z is what will be added to what? To Y, and this X is against the two direction, which is minus X equal to 0. We don't have this kind of answer in the option. Do we have it? We have it? No. We don't have it. Okay. Let us arrange this formula again. We can say that what this one can be X is equal to what? Z plus Y. Is this one there? Yes. That will be option B. So the answer is B for this one. So thank you for watching. I believe you enjoyed the class. Please write your comment or type something in the comment section to encourage us to know whether we are doing well or not. Thank you. God bless you.